Okay, so we're taking a look at the derivative of a piecewise function. We see the notes already here. We already see that in the conclusion, we have the conclusion that f prime of 1 does not exist. So why is that? And for that answer, we go to the definition of a derivative that we see in the work up above. The thing to pay attention to is that because we're dealing with a piecewise function, we want to analyze the limit from either side of 1. So what we're going to see here is that we're going to approach this first of all as h approaches 0 from the positive, and that would give us values just to the right of 1 if h is positive. And then we'll notice that that limit's going to go to infinity, which we'll see a visual of that in just a moment. And the case where h is approaching 0 from the left, or from negative values, that's going to give us a situation where we're analyzing the tangent as it's approaching 1 from the left. And again, we'll go to a visual on that. But what's interesting on this is that this is defined, and if you take a look at the work going from both limits as h is approaching from the positive and h is approaching from the negative, if you notice here with the minus f of 1, we're subtracting 1 in both cases. And the reason being is that if you take a look at the piecewise function up at the top, x is less than or equal to 1 applies to the expression x to the 4th. So in both limits, we are only subtracting 4 or subtracting 1 in the numerator, not subtracting 4 at any point. And as we watch the limit unfold from both directions, we see that from the right we're approaching infinity, and then from the left we're approaching 4. And because those are not matching, that tells us that the limit does not exist. And since the limit does not exist, nor does the derivative. So how does this actually look in practice? So again, we have to look at what's happening from the left and from the right of 1. And I have a little visual here of that situation. So what we're looking at in purple is going to be the secant, but for what we want to do is, if you look at the h slider, we want to make the secant a tangent, so we want to take h to 0. So C will drag h, but notice that h has negative values. We're going to approach 0 from the left. So as we look at this, you can see the secant becoming closer to a tangent once it equals 1. And we're getting closer and closer, and at 0 we actually lose it because Desmos doesn't know how to do limits yet, so it's going to actually try to divide by 0. But if we go to negative 0.1, you can kind of see that we have this tangent that has a slope equal to 4 approximately. So that was the idea as h is approaching 0 from the left, that hits 4. Now if we go to the other side and approach h going to 0 from the positive, we see the secant now is cutting through both pieces, and as h gets closer and closer to 0, take note of what's happening here when it's trying to make a tangent. So we'll go to 0.1 just to kind of get to the point, and if you notice, we have this purple line that's supposed to be the tangent that really looks like to be vertical. And what we know about slopes of vertical lines, we know that to be infinity. Take note also that it's approaching positive infinity. If you take a look at the slopes, it's getting steeper, steeper, positive, and we can come out with this positive infinity, which if you go back to the notes, that is what is happening with the limit as h is approaching 0 from the positive. We come out with a limit equal to approaching positive infinity. So that is a little segue problem into the existence of derivatives. We'll stop here and continue on to the next page of the notes.